Alright, so the chord-chord power theorem states that the segments of each of these chords I have here, so A times B is going to be equal to C times D. So I'll be proving this first. So I'll just draw the same, another circle, these two intersecting chords. I'll call this A, B, C, D, E, and I'll call this A, B, C, and D, lowercase, just like before. Now I'm gonna connect A and C, and B and D. So I'm gonna prove triangles ACE and BDE similar. So we can say that these two angles are congruent because they're vertical angles, and this is congruent to this because they intercept the same arc over here. So now by the AA theorem, we can say that triangle AEC is similar to triangle BED, and we can say AE over BE is equal to CE over DE because corresponding sides of similar triangles are proportional. And then we can say that AE times DE is going to be equal to BE times CE, because the product in a proportion, the product of the means equals the product of extremes. And we can see we see that AE is A. We said that earlier. AE is A. DE is B. BE is D. Or I'll put it in different order. CE is C, and BE is D. So this is what we said earlier. So the segments of these intersecting chords, their products are going to be the same. Okay, so the next power theorem is the tangent-secant power theorem. So I have a circle here. I'm drawing an external point here, a secant, and a tangent. This is not drawn well, but you get the gist. Okay, so the tangent-secant power theorem states that. Okay, so I'll label this T. I'll label this E for the external part of this secant, and I'll label this S. So the tangent secant power theorem is basically this tangent squared is equal to the external part of the secant multiplied by the length of the the length of the whole secant. Okay, so I'll redraw this. We have an external point, a secant, and a tangent. I'll call this A, B, C, and D. I'll call this T, E, and this whole thing S. Okay, so we can draw two auxiliary segments here. We can connect this, and we can connect this. So my goal is to prove triangle BDC and triangle ADC similar. So these two triangles have share a common angle, angle C. So we have one angle now, and we can say this angle over here is congruent to this angle because angle BDC is half the measure of this arc, and this is because angle BDC is half the measure of arc BD because it's a tangent chord angle. If you don't already know that, you should learn about it. And angle BAD is half the measure of arc BD for the same reason, because it's an ascribed angle. And if you do not already know that, for the same reason. Okay, so now we can say triangle ADC is similar to triangle DBC, and we can say no, not AD, because that's not part of what we're proving. So DC over BC is equal to AC over DC, because corresponding sides of similar triangles are proportional. And we can say DC times DC equals AC times BC. And so same thing as DC squared equals AC times BC. And we can substitute for these letters we put down earlier. So DC I had T, so T squared equals AC, which is the whole secant. I'll put that here. Times BC, which is the external part of the secant. And so this is the tangent-secant power theorem. For the last power theorem, this is the secant-secant power theorem. So I have an external point over here, and I'll draw a secant over here and another secant to this common external point. So the secant-secant power theorem states that, okay, so I'll label this E1, the external part of secant segment 1, and I'll label this whole secant segment S1. I'll label this E2 and this E2 and S2. So the secant-secant power theorem states that E1 times S1 equals E2 times S2. So I'll just redraw this real quick. Oops. Okay, so circle, external point, outside the circle, two secants. And I'll call this A, B, C, D, E. And I'll call this E1, S1, E2, S2, like earlier. Okay, so first we can draw auxiliary segments like again. So we can draw E to B and A to D. And so my goal is to prove triangles ACD and triangle ACD and triangle EDB similar. So we can say that this angle is congruent to this angle. Okay, I'll get that to I'll get to that later. Okay, so angle C is reflexive. That's the first thing I noticed, so I'm gonna go over that first. So since we have one angle now that we know angle C is reflexive, and we know that angle A and angle E are also congruent because they intercept the same arc. So now we can conclude that by the AA theorem that triangle ACD is similar to triangle ECB. And now we can say AC over EC is equal to CD over CB, because corresponding sides of similar triangles are proportional, and then we can say AC times CB is equal to EC times CD, because in a proportion the product of means equals the product of extremes. And then we can just substitute for what we said they were earlier. So AC we have here as S1, CB we have as E1, EC we have as S2, and CD we have as E2. And this is a secant-secant power theorem that I mentioned earlier.